Hi everybody, I'm Parth Sharma.
And I am Megha Singhal.
We are pursuing BTech in EC branch from Jaypee Institute of Information and Technology, Noida. We are doing a project named Boston House Pricing under the guidance of Skyfi Labs. Before getting our hands dirty with Python programming, I'll share a few details about the topic. We are doing this project using machine learning algorithms. We will use the linear regression model here. Yeah, so let's dive into the code quickly.
So here's the code. First, we'll import the required libraries. NumPy, which stands for Numerical Python, is used for manipulation and creation of arrays. Pandas is used for manipulation of tabular data. Matplotlib is used for plotting. We'll use sklearn for loading dataset, for mean square error, for splitting dataset, and for min-max scaling.
Now, I'm loading the data set and printing the description. And here's the description with all the attributes. So, we'll extract the features in target from the data and store it in the variables features and target respectively. Here, I'm printing the first 5 rows of features in target. Then, we'll do concatenation of features and target and store it in the variable df. Following this, we'll round off the value stored in df to 2 decimal places.
Now, we'll find the correlation between attributes and target. Here, we have to find which attribute is highly correlated to target. We are using Pearson coefficients for this purpose. Here, we can see the correlation and feature list are zipped in the list L. Using the sort command, we'll sort the list L in decreasing order. Then, we have to unzip it in cause and labels variable. Here, labels contain the attribute name and cause will have attribute data.
Then, we'll arrange the labels in NumPy array form and store it in index. Now, we'll plot the graph between correlations and attributes. From the graph, we can clearly see that LSTAT is highly correlated with the target. Due to having highest correlation with the data, we'll use LSTAT for further proceedings.
The next step is normalization of the data. Here we'll fetch all the LSTAT data into X and all the target data in Y. By using min-max scaler, we'll scale X and Y. Sequentially, we'll remove the extra dimensions by the array slicing operations. Now we move forward toward splitting the data into training and testing set. Here we keep the test size equals to 0.2.
Now, we'll use the gradient descent algorithm to minimize the slope. Gradient is the other word used for slope. The gradient descent algorithm is implemented with 3 functions: update function, error function, and gradient descent function. This error function is used to compute the cost function value. The purpose of this update function is to update the weights so that the weights get closer to their final values. Now, the gradient descent function is used to implement the gradient descent algorithms using the above defined 2 functions. In the gradient descent function, we'll start with an initial assumption for m and c. Then calculate the cost function, then gradient at current position. Now determine the direction to move. Lastly, we'll update m and c based on the learning rate. Here's how to run the gradient descent function. Time is a magic function here, and yeah, it returns wall time is equal to 951 milliseconds.
Okay, so now I'll carry forward the discussion towards Visualization of the learning process. First, we'll plot the regression line against the training data set to visualize what the line looks like for the training data set. Now we'll plot the error values. This graph will show us how the error drops over the time. For more fun, let's generate an animation that will show us how the regression line changes over the journey of training. To limit the processing time of the animation, we limit the number of M and C values by selecting every fifth value. Now we'll initialize figure and axis, then initialize the line. The same object is used by init and update functions. This init is a callback function which initializes the graph. This update function is used to update each frame. Then declare the animation object. There's one thing I would like to mention here. In the project video, we were told to use two HTML5 video function, but due to compatibility issue in our system, we used 2JS HTML function.
And here's the animation. Taking the discussion towards the end, we'll see the prediction of values after the training of the model is completed. First, we'll generate a list of predicted values using the line equation and store it in the variable predicted. Now, compute mean square error for the predicted values on the testing set. Observe that the mean square error is quite low. Then, put x-test, y-test and predicted values into a single data frame with a zip function so that we can see the predicted values alongside the testing set. Now, plot the predicted values against the target values. Now, we'll revert normalization to obtain the predicted price of the houses. We'll use inverse transform to scale the values back to normal representation. Again, using the zip function, we'll display the predicted values and actual prices side by side. See, our efforts are embraced. We have the predicted values close to the target values. So, here's what we had at the end of this joyful journey.
Thank you.
Skyfi Labs